Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to talk about continuous functions. So in college algebra we say that a function is continuous over its domain if you can sketch its graph without having to lift your pencil. Now we'll come up with a different definition of that when we get into calculus, but for now it rings true. Here I want you to draw the graph of a function that has a discontinuity, meaning it's not continuous at the given value or values, and state the levels of continuity, or the intervals of continuity. So the first one says at x equals 3, it's not going to be continuous there. So at x equals 3, I'm going to draw one that looks like this, where it's just not defined at x equals 3. Now, I could also define it at x equals 3 somewhere else, but I can't draw that graph without lifting my pencil off the paper. With the first graph I drew, I would either have to take it off just as I made it to 3 and then put it down again on the other side of 3, or I would have to take the pencil off the paper to put the dot up above higher. Now the intervals of continuity, that's everything except for 3. So it's the set of all x. Actually, I'm going to just write it in interval notation. And that would be from negative infinity to 3, union from 3 to infinity. That's the way that we write all real numbers except for 3. In the second graph, I want the discontinuities to be at x equals -1 and x equals 5. So let's have a rough sketch of a graph. I've got -1 here, +5 over to the right, and I want it to be discontinuous at both of those places. So first, I'm going to draw something to the left of -1, and then I'm going to jump up, and we do call that a jump discontinuity later. I'm going to jump up a little higher and draw another segment down to 5, where x is 5, and leave an open space there. And then above that, continue the graph like that. So this is a function because no value of x has more than one function value or y value associated with it, but it does have those two discontinuities. So this would be from negative infinity to -1, union from -1 to 5, union from 5 to infinity. Now there are other kinds of discontinuities as well, including places where a function is not defined. For instance, a rational function where we're divided by 0. But any of these are good for this. In the next series of videos, we'll talk about graphs of basic functions, and then we'll get to a function like the one I have on the screen, which is what we call a piecewise function, where it's defined in pieces rather than one definition for the whole function.